All right, well, this is the first official video on the chain rule. I know you guys have already seen it, but we're just going to talk about it a little bit more. So this is the official definition of the chain rule, but we are probably going to usually just look at it like this, and it really is the same thing. So you got the derivative of what we could kind of call the outer function times the derivative of the inside function. And to do this, there's two ways to kind of think about this. So the first is, if you were taking the derivative of this, you would just say, okay, dy over dx equals 2x, and then you could think about the derivative of the inside, and the derivative of x is technically just 1. And so this just equals 2x. But what if we did something a little bit differently? What if instead we thought about this as implicit differentiation? What I mean by that is that this, we're going to take the derivative of y and we're going to take the derivative of x squared with respect to x. Well, the derivative of y is just dy, and the derivative of x squared, well, that's still 2x. But we have to multiply by the derivative of the inside, so what's the derivative of x? Well, that is dx. And now, well, we could divide by dx, and look, we get the exact same result, 2x. And so we're going to kind of use this idea to do these problems. And eventually, the dx is always just going to be on the bottom here, and so we're always going to get dy over dx. But the idea is for you to see kind of this pattern that starts to evolve when we do the chain rule correctly. All right, let's go to the next page. Okay, without the chain rule, you could still do this derivative. You could expand this thing using Pascal's triangle. And so if I expanded this, I would get that this is 1 times 2x to the fourth plus 4 times 2x to the third times 3 plus 6 times 2x squared times 3 squared plus 4 times just 2x to the 1, but also times 3 cubed, and running out of room here, plus this would just be a coefficient of 1, and this one would just be 3 to the fourth. So I haven't taken the derivative yet. All I did is use my Pascal's triangle to expand it. Notice the 1, 4, 6, 4, and technically there's a 1 here to expand it, and then I just did the pattern of the first term to the fourth, third, second, first, and then 0 power, and then the second term to the 0, 1, 2, 3, and then fourth power. So let's clean this up a little bit. This would be 2 to the fourth power is 16, x to the fourth plus, I have a 4 times 3, that's 12, and 2 to the third is 8, so 8 times 12 is 96, x cubed, plus 2 squared is 4, 3 squared is 9, 4 times 9 is 36, and 36 times 6 is 216, and we do have an x squared there, and then we have 4 times 2, which is 8, times 27, that is also 216, and that one just had this little s, and then finally 3 to the fourth, that is 81. Okay. The point is we could expand all this, and then now that it's expanded, we could take the derivative, right? So the derivative of y, or y prime, this would just be 4 times 16, which is 64, x cubed, plus 3 times 96, 288, and then there'd be x squared. And then 2 times 216, that would be 432. X plus 216, and then there would just be plus 0. Okay, so we could do all that. Or we could do the chain rule. And so I'm just showing you the usefulness of the chain rule here. Let's use substitution like we've used in a few other videos before. And we're going to call this part inside here u. So u equals 2x plus 3. Therefore, du would equal, well, what's the derivative of 2x? It's just 2. And let's go ahead and say, I haven't done this before, but let's say, what's the derivative of x? Well, that is actually dx. And the derivative of 3 is just 0, right? Okay, so let's rewrite this. This is like saying y equals u to the 4th. And so what's the derivative of y? Well, it's dy. And what's the derivative of u to the 4th? Well, it's 4u cubed times du. Let's plug everything in. We get dy equals 4 times 2x plus 3 cubed times 2 dx. Okay, well, we could simplify and divide both sides by dx. And we end up with dy over dx equals, I'm just going to go ahead and do 4 times 8 here, or 4 times 2 to get 8, which is 8 times 2x plus 3 cubed. Okay. And if you wanted to, you could expand this thing out, and you'd get the exact same thing as up here. I encourage you to go ahead and try it just to double check, but you would get the exact same thing. And you could see that this way was obviously a lot quicker. So the chain rule becomes very useful. Okay, we can also kind of just do the chain rule without using u substitution. I'm going to show you how we could do that. Well, the derivative of y we're going to write as y prime. And I'm first just going to ignore what's inside the parentheses. And I'm just going to say, well, what's the derivative of something to the 4th? Well, it's 4 times that something to the 3rd. And then we just have to account for the derivative of the inside. The derivative of the inside is 2. So they both work. They get us the same derivative. Just two different ways of thinking about it. So I'm going to show you the same process here. But instead of the 4th power, what if it's the 40th power? So we have two ways. I'm going to do one with u substitution and one without. We'll get the same thing. I prefer u substitution, though. I think it makes it a lot simpler. So I'm going to make my u equal the inside again. It's 2x plus 3. Therefore, my du would just be 2 dx. And so when I go to write this, I'm going to say that y equals this. And so dy equals, hold on, that means this is like u to the 40th. So dy equals 40 u to the 39th du. Then I could plug this in. dy equals 40 times 2x plus 3 to the 39th times 2 dx, and divide by dx. And so I get that dy over dx equals 2 times 40 is 80, 2x plus 3 to the 39th. And remember, dy over dx is the same thing as f prime of x. And so we could do the same thing here. It's the exact same problem, but now I'm just not going to use the u. I'm just going to kind of think of it as the derivative of this whole thing and times the derivative of the inside. And so there, maybe it's a little bit quicker. But this is a good habit to get into, especially as things get harder and harder. And when we get into integration, you're going to be very thankful that you're well familiar with u substitution. But this is a pretty simple problem because the derivative of something to the 40th is just 40 times that something to the 39th, and then times the derivative of the inside, which is 2. And so we get 80 times 2x plus 3 to the 39th. So same thing both times. Just want to show you there's two different ways of handling it. I know that this way seems like more work, and a lot of problems you'll be able to do like this pretty quickly, and that's fine, but you're going to want to know how to do this because there's going to be problems where you really, really need to be organized and have it all kind of laid out for yourself. All right, let's go to the last page. So first one again, I'll do u substitution. U is going to equal x squared. That's a u whether you like it or not. And du then would be 2x dx. And so y is really like saying the sine of u. And so dy would be the cosine of u times du. And so this equals the cosine of x squared, because that's what u is, times 2x dx. But again, I'm going to divide both sides by dx. And so here's your derivative. Typically we would write the 2x in front, so let's just rewrite it real quick. It would look more like this. Yeah, that's a better way of writing it. Okay, and without the u substitution we could do that as well. Remember, that would just be y prime. The derivative of sine is cosine times the derivative of the inside, and we get the same thing. So I get it. I hope that you can do a lot of problems like this. I know that you're going to need this skill later. So some of them you'll be able to just quickly see. It's just the derivative times the derivative of the inside. But there are going to be problems that are a little bit more complicated. Okay, there's part A of the chain rule. We get some more fun ones on the next couple videos.